when dividing complex numbers, the objective is to get rid of the imaginary in the denominator. And these are the two strategies that will produce that. So let's look at an example. Let's say we have 9 plus 3i divided by negative 5i. So two complex numbers, we're dividing them. And since the denominator is a monomial, what we can do to make it no longer imaginary is to multiply the numerator and denominator both by I. And we can do that because it's a fraction rule, multiply the numerator and denominator by the same thing. And if we do that, the denominator is going to be negative 5i squared. And there we go. There is that number that we see that is no longer imaginary. So I squared is negative 1. So this is now negative 5 times negative 1, which turns into just regular old real 5. So that's why we multiply by an I, because that I is going to combine with the other I and no longer be imaginary. So we achieved our goal for the denominator, and then we just need to simplify our numerator. So the 9 plus 3i times I is 9i plus 3i squared. There's another I squared, which is nice. We can turn that into something real. So that's 3 times negative 1. So our overall numerator is going to be 9i minus 3. And then we can take this one step further and just split this into our real number and our imaginary number. Just divide each part by the 5. So the negative 3/5 plus 9 over 5i. And we would reduce those fractions if either of them could be reduced. So again, now we have our real part and our imaginary part. Okay, let's look at a division where the denominator is a binomial. Let's look at 8 plus 6i divided by 3 plus 9i. Okay, here if we multiply the denominator by I, we're going to be left with a 3i plus 9i squared, which this is no longer imaginary, but the 3i is still imaginary. So multiplying by I doesn't help. So there's a special technique that is used for imaginaries as well as radicals called multiplying by the conjugate. So what we're going to multiply by is the conjugate of the denominator, which is the 3 and the 9i again, but you do the opposite sign. So this was plus, so there we're going to use a minus. All right, and remember, whatever we do to the denominator, we have to also do to the numerator. But here we have our conjugates, this and this. Now we'll see what happens when we multiply this out. And let's start with our denominator. So when we multiply the denominator, we have a 9 plus 27i minus 27i minus 81i squared. Now, some things I see. I squared is negative 1, so that's good. And 27i minus 27i cancel. And that is guaranteed to happen anytime you multiply by a conjugate. The middle terms are going to cancel each other out. So our denominator turns into, this becomes negative 81 times negative 1, so just positive 81. So our denominator, let's bring it down here. We'd have 9 plus 81 is 90. And just 90, that's great. Just one real number, 90. So we just achieved our denominator goal. And then the numerator, we have to multiply all that out. So that would be a 24 plus 18i minus 72i minus 54i squared. Well, again, there's another I squared. So when we combine all that together, the numerator is going to become a 78. Change colors. 78 minus 50. What is that? 56i. Let me check that real quick. Sorry, 54i. Okay, and then that last step is to, again, split it into the real part and the imaginary part. So 78 over 90 minus 54I over 90. 13/15 minus 3/5 I. Okay, let's look at one more here together. Here we have a 2I over 4 plus 9I. So I'm just going to work this out as one extra example. The denominator is a binomial, so I'm going to multiply by the conjugate. So it's 4 and 9I, but since it was plus, it's now minus. If it started as a minus, then I'd put a plus. All right, numerator, 8I minus 18I squared. And the denominator is going to be 16 minus 36I plus 36I minus 81I squared. Okay, so the numerator is going to become positive 18 plus 8I. And the denominator, which becomes positive 81, would become 97. And so we're all real on the denominator, so now we would just split it up into our real part and our imaginary part, and then reduce if possible. Okay, why don't you try this one, pause and try this one. All right, let's do negative 8 plus 2I over negative 1 minus 2I. All right, that is equal to 4/5 minus 18/5 I.